Let's walk through the solution to this assignment. We were tasked with running a flow analysis on air moving through this elbow. We began with our part and a fluid domain represented by CAD. First, we isolate our outlet and our two inlets. The inlets are these top two CAD faces, and our outlet is here. We know that to run a flow analysis, we need three main inputs: our model, our boundary conditions, and our cell size. Let's start by creating our simulation model. To begin creating our simulation model, we'll create a fluid domain. This fluid domain represents both the geometry and the properties of our fluid. To specify our geometry, we can easily generate an implicit body from our imported fluid CAD and drop it in as our first input. To influence the behavior of our fluid in our simulation, we can add a fluid attribute and use one of our pre-built isotropic materials, air, that you can find in our Fluids tab under Material Information. We can then add this fluid domain to a simulation model block, ignore our connectors input, and we've completed setting up our simulation model. Now we can move forward to creating our boundary conditions to specify our inlet velocities and our outlet pressure. We'll start with our two inlets. We can use velocity blocks that we also find in our Fluids tab under Boundary Conditions. And unlike our follow-along exercises, where we were specifying inlets and outlets on an implicit body, now we're specifying these on CAD faces. We can use the drop-down in our velocity block to specify a CAD face list and a vector, rather than an implicit boundary and a vector. This allows us to use those individual CAD faces that we specified for our inlet 1 and our inlet 2. In this case, we can generate these velocities quickly and easily. To specify our outlet pressure, we'll use a similar process, adding a pressure boundary condition to our notebook, using the overload of that block to specify a CAD face input, and using our outlet CAD face and our pressure magnitude. We can view our outlet pressure like so. We'll add all three of those boundary conditions to our boundary conditions list in our flow analysis, specify a cell size of 5 millimeters, isolate our results, and use the Display tab in our right side panel to view our streamlines and toggle through our results options using the heads-up display. Say I want to visualize the streamlines of the air only entering through the smaller inlet. I could specify a seed, drop its center to that smaller inlet, adjust my radius to make sure that I'm capturing my inlet, and now I can visualize the streamlines of only the air that enters that smaller inlet.